Hello, I'm Ms. Holland.
And I'm Mr. Valentine.
And today we are going to be talking about Unit 2, addition and subtraction with whole numbers and decimals. Now, in Unit 2, the students are going to be expected to be able to add and subtract using whole numbers with decimals up to the thousandth place. The students are also going to be expected to...
They're expected to be able to work with pictorial models, estimation, and then with perimeter with whole numbers and decimals.
Okay, so let's get started. For example, let's take 45 and 200. Okay, I'm going to add, let's say, 23 and 6300.
Whoa, Miss Holland, why did you line it up like that?
The students are expected to be able to remember, well, not be able to remember, but we expect the students to always line up the decimals. That is one of the key components of this lesson. They need to remember to line up the decimals whenever they are adding or subtracting using decimals. So let's go ahead and do this. 3 and 2 is?
5.
0, 6?
Is 6.
Keep on going. 8 and 6.
And 6.
Now we have 68 and 6500. Okay? So we always want to point out for the students to make sure they line that up, because that is one of the biggest misconceptions when adding and subtracting decimals. Okay? Also, student, with the pictorial models, okay? This is a hundredths grid. We look at this as a whole. Okay? This will be the unit. There are 100 units to make this whole. This is our longs, which is the tens piece. Okay? There are 10 of these in the hundredths grid. So, students will be using pictorial models as well to represent adding and subtracting with decimals. So, say for example, I ask the student to shade in 45 hundredths. They should automatically know that this right here represents 10. So I'm going to shade in 4 of these. So that's 10, 20, 30, 40, and then I need to count how many more, Mr. Valentine?
5.
5. 1, 2, 3, 4, 5. So I have 45 hundredths. And if we were to add to 45 hundredths, we were to add, let's say, 23 hundredths. The student should automatically know, let's go ahead and add, let's say, 1, 2, that's 20, 1, 2, 3. So we have 10, 20, 30, 40, 50, 60, 61, 62, 63, 64, 65, 66, 67, 68. 68 hundredths shaded in. Let's do the addition on the board. 5 and 3 is 8. 4 and 2 is 6. So you have 68 hundredths. 45 hundredths and 23 hundredths equal 68 hundredths. They will also be expected to show that on pictorial models.
Okay, now we're going to talk a little bit about estimation. I want to take the same number that we have right here, it's 45 and 200ths, and it's 23 and 63 hundredths, and do a little bit of estimation with it. First and foremost, though, I need to clear my board here. So, when we're estimating, especially when we come into whole numbers, we're going to look to the first spot after the decimal place, in our 10th spot. So, right here, I look over to my 10th spot and I see a 0. So right now, I can keep my number here at 45. No need to add anything else to it. And right here I have my number 23 and 63 hundredths. I see right after my decimal is a 6 in the 10th spot. So I'm going to round my number up to the next whole number. And when I do that, it gives me a roundabout area for where my answer should be at. 5 and 4 is 9. 4 and 2 is 6. And voila, when we look here, we see that even our answer, 68 and 65 hundredths, can also be rounded to our answer when we rounded our two numbers there. Now, estimation is a skill that students have been working on ever since their early years in first grade. It's a skill that they need to master in fifth grade to be successful on their unit test in this class and also the STARS test. It is important for them to be able to have this skill mastered above all other skills in here.
And I'm glad that you pointed out for students to be able to master that, Mr. Valentine, because estimation, like you said, when students are rounding or using a logical guess for their answer, they must also turn around and compute that so they can justify their answer. When we ask students to justify the answer, we want them to explain, to show us how they got that answer.
Can we do an example of justification here?
Exactly. Go ahead.
Okay. If I was to take this number here, and it's close to the number that we're going to use right there, and I was going to add it. Matter of fact, let's go with subtraction this time, because we haven't talked about subtraction yet.
Yes, this is subtraction.
And I was going to subtract this number from here. And I wanted the kids to estimate what the answer would be before they did it. So, could you help me out and tell me what would we round these to?
Let's take the top number. We can go ahead and round that off to 25.
Okay, so we'll round this one off to 25 as the whole number.
And I'll take the bottom number and go ahead and round that off to 11.
And 11 here. Excellent. Okay, so can you help me out with this math problem, Miss Holland?
5 minus 1 is 4.
Excellent.
2 minus 1 is 1.
Is 1. Okay, so our estimated answer right now would be 14. So let's go back and do our actual computation and compare our estimation to our actual algorithm computation that we're going to do right here. So we have 8 minus 2 is 6. 7 minus 3 is
4.
Okay. And then we have 4 minus 1.
3.
Oops. Make sure we write that in nice and clear. And then 2 minus 1
is 1.
Is 1. Now we can take a look right here between our estimation and our actual answer, and we can justify that our estimation is relatively close to our actual answer, and that was a reasonable estimation to have for our problem.
Okay, very good. Now, Mr. Valentine, I want to touch on perimeter.
Ooh.
Okay?
Perimeter.
Now.
That is a scary, scary term that some of you kids might get freaked out about, but don't worry.
Let's talk about perimeter. Now, perimeter is the distance around an object. Okay? Think about this word, rim. You know you got a basketball rim? You got the rim.
Swish!
Okay, did you hit any of the rims? The distance around an object. Okay? So, the students are expected to be able to find the perimeter of rectangular shapes along with other polygons. Okay? For example, if I was to say that I had let's see. What do we know about a rectangle?
A rectangle, it has two sides that are equal and the other two sides are equal?
It has at least 2 equal sides.
Wow.
So say, for example, the side of this rectangle is 45 and, why do I keep pulling the same number, 200. And let's say that this side of the rectangle is about...
Let's say about 32 and
42 and 4200. The students will be asked to find the perimeter of this rectangular, and 2 sides may be missing. So we know that a rectangular shape has 2 equal sides at least, right? So therefore, if this side is 45 and 200 and this side is supposed to be equal, that makes this side
the same. 45
and 200. And if this side up here is 32 and 4200, then this side down here will be 32 and 4200. Now what do I do when I have all this information?
Ms. Holland, I think I should add them all together.
Yes, exactly. Perimeter is when you add up all the sides. And actually in 4th grade they had a little song where they sung, here we go around the perimeter, the perimeter, the perimeter. Here we go around the perimeter. We add up all the sides, all the sides, all the sides. Every time, every time, every time, every single time you add up all the sides. So therefore, I'm going to take 45 and 200 plus 45 and 200. I get 4, 0, that's 10, 4 and 4 is 8, plus 1 is 9. So for these 2 sides so far, I have 90 and 400. Okay? So let's do those 2 sides. You want to go ahead and do that for me?
I'll take these 2 sides right here. So we have 32 and 42 hundredths and 32 and 42 hundredths. So I'm going to add these together. That's 4. That's 8. That's 4. That's 6, so that's 64 and 84 hundredths.
Now, what I'm going to do is, because now I have the total of these two sides, realize I said total, which is the key word for adding, and then you have the total of these two sides. You're going to take the total, and you're going to add them together, 90 and 4 hundredths, plus 64 and 84 hundredths, to get your perimeter. So, the perimeter of this rectangular object right here will be 154 and 88 hundredths.
Now, Miss Holland, couldn't we also had estimated to figure this out?
We sure can.
Oh, wow. So how could we had did that? Could we had made that two sides that are right here, both just 45?
Correct. And we know that 45 and 45 will be
90.
And we could have made these two sides 30.
So we have 30 and 30.
Which would be 60.
Which is 60. And then what is it? 90? Come down here.
90 and 60, because we know that 9 and 6 is 15, so we're going to have 150.
Wow.
Now, this is estimating. So therefore, our estimation is close to our actual answer. So we can justify that answer.
So kiddos.
Now, I also want to give them an example of the performance indicator that they're going to be expected to do by the end of this unit. Let's say, for example, Mr. Valentine, let's see. Okay, let's say, for example, you have a square-shaped.
What a garden.
A square-shaped rug, okay? A square-shaped garden, okay? Let's just say garden. Okay. You also have a rectangular-shaped garden. And another rectangular-shaped garden. Okay? Let's say, for right here, the size will be 8 and 2/10. The size right here will be, let's see, 11 and 43 hundredths. And this side down here will be 6 and 5/10. And let's say again, 6 and 5/10. So let's make this one right here 13 and 5. I don't want to write it too close to this figure. 13 and 5/10. Now, why didn't I write another side on here?
Well, because a square has 4 equal sides.
It does. So I don't have to write another side on it because all of them are the same length. So therefore, if this is 8 and 2/10, then all of these will be 8 and 2/10. So, now, the problem that I'm going to give you, Mr. Valentine, is let's say that I go to the store and I go find some flowers to go around, not flowers, but trimming to go around the garden.
All right.
Okay? I come back with a total of, let's say, 250 feet worth of trimming. I want to know if I have enough trimming to go around these 3 gardens.
Wow.
I only have 250 feet. So, how would I find out whether or not I have enough trimming to go around these 3 gardens?
Well, I think that we would find the perimeter for all 3 of your different gardens and then add those totals together.
You're right. So we must first find the perimeter of each garden.
Okay.
Once we find the perimeter of each garden, we're then going to add it together. And then we're going to see if our number is less than or greater than the actual amount of trimming that I have. Okay? So I will go ahead and do this. Let's just say 8 and 2/10. We have 4 sides. Can I go ahead and multiply that by 4?
Yes, ma'am. You can actually multiply that by 4.
And see, I'm estimating that this is going to be about 32, because 8 times 4 is 32.
That is a great estimation.
So let's go ahead and compute this. Remember my decimal? So this is 32 and 8/10. So this right here is actually